So, uh, first of all, I'm Afolabi, as you all know. And for those that were in our previous class yesterday, because I know one of us years wasn't available. So we discussed about LCDs and what they were, how they function, how you can use it, and other things like that. And I also gave an assignment. Anybody who has done it, just signify by raising your hand. If you don't done it, it's fine. So just you don't know if anybody has done it. See, seems like nobody has done it yet. So, by the way, can you all hear me perfectly? Okay, that's good. That's good. So, since no one has done the assignments, thinking, should we start with that? If we should start with that, should I say answer or just proceed to what we have to do? To start with that. All right then. So let's share my screen. All right. So I take it as
Sorry, were you asking assignments?
yeah, I didn't hear what you said.
Were you asking about the assignment?
Yes, I did ask that. Has anybody done it?
Okay. I've done mine already.
Oh, that's nice. I don't think I should clap for you,
Yes.
but that's very nice. That's very nice. Okay, and it's worked correctly, Abby.
And it's showing distance 112.1 centimeters. I don't know. The distance is changing between 112 and 110. I don't know if that's supposed to be the case. And it's showing out of
Yeah.
range. Let me just share my screen.
Okay. Okay.
Come on. I guess come on. Can you see it?
Yes. Let me
So this
stop sharing my
is showing.
I'm not focused on
The
yours.
distance is fluctuating a bit. I don't know if you're supposed to do that. 110 and 112.
Okay. So what you can do is click on your sensor, try to adjust the distance. Use that green. Yes. Try to adjust it. You can move it closer. And did it change on screen?
Yes, it did.
Okay. Okay. It's working perfectly then. That's very nice. Well, I do have a present for you. Just remind me after the class, so I'll send it to you.
No problem. Thank you very much.
Is that all right? Yeah. Yeah.
Yeah, thank you.
Yeah. So since like it seems like we all understood what was taught yesterday, so we'll be going to today's class. Going to today's class, and that's going to be about more on LCD apparently, and how you can connect LCD, use it with other things and other things like that. So, first of all, I'm going to do some theory before we go into the practical. So, okay, yeah, if you can remember correctly, yesterday I made mention of the I2C protocol that the LCD, like the new batch of LCD, use to like what do you call it, to communicate with the Arduino rather than working with 16 pins, right? So I'm going to be speaking more on how that actually works. So, first of all, I made mention of two things yesterday. Uh, Apart from the power line and the ground line, two wires that the LCD and I2C LCD uses to connect to an Arduino, I made mention of the SDA and the SCL. So now, if I want to explain, I did explain the SDA and SCL yesterday, but I want to give you an in-depth explanation of how they actually work. So now, let's use our what do you call it now? Our visualization. So when, for example, when the Arduino wants to talk, let me full picture and comment. Picture for you guys. Understand what I mean? Okay, comment. Okay, so a picture. Let me change screen to the picture. You can see it. Can you all see this very well? Or should I zoom in? Okay. Okay. So no. So the SDA, okay, SDA and the SCL are just two wires that convert whatever the 16 pins of the Arduino wants to push forward to just two wires instead of 16, right? So, and the way they do it is the SDA and the SCL translates whatever wants to go on both ends of the spectrum to the Arduino. So sorry, I'm skipping. So to the Arduino. Now, what I wanted to say was the SDA and the SDL start the same way every other device or every other thing I've explained to you starts in Arduino development. Starts with the high and low, right? So now, when the Arduino wants to talk, it pulls in the SDA. So the SDA is low, pulls in SDA low, then, and you know, since it's vice versa, when the SDA is low, the SCL is going to be high. So now, what this signals is, it tells the Arduino that, oh, sorry, the Arduino tells the LCD that, okay, I'm about to send a message to all devices on this bus. Now, so if you can look at this address frame, you can see that if you can look at the address frame, you can see that it's 7 bits, right? This 1, 2, 3, 4, 5, 6, 7, right? It's 7 bits. So, and every LCD is 0x20. That's the 0010000. That's the default address. So now, when the Arduino gets this default address, the Arduino sends the address first and follows it by a read-write bit. Now, what that means is this, I don't know if you guys can get what I'm trying to say. Okay, so these first 8 numbers, those are the killing this 1, 2, 3. So See 8 to 7. Okay. First 8, that's the normal address address frame, and the last one is the right bit. So if W is equals to 0, it means write to device. And if W is equals to 1, it means read from device. Are you getting me? Or should I come again? Okay. So
Hello,
now,
sorry. Oh, you said the address are 8, but I'm seeing the address this thing pointer is point to 6. This thing.
1, 2, 4, 8. These are 8.
Okay, that means this address points to all these.
Yeah,
But I
it is
thought
not
it
a
was
it, it is not arranged correctly. Sorry. So it's 8 bits. First address, then the last one is the read or write bit. Let me find a picture that's better. Let me find it. That's good. Should have one that is better. Come on. So, sorry, I'm trying to like find another picture that is better. Okay. Now, can you see it better now? Okay. So our address frame, 8 bits. This this first numbers is the address that the Arduino either calls or writes or reads from. This is the specifier. So if W is equals to 0, means that it should write. If W is equals to 1, means that it should read from device. Is it clear this way? Okay. Now, after
Sorry,
this,
can you repeat that? I didn't get you clearly.
okay, address frame is 8 bit, right? And from the beginning, I said that the LCD has 0x20. That's the binary. That's the normal address. That's the I2C LCD address. Is 0x20. Now, when you convert that 0x20, that's 0x20 to binary is 0010000. That's this, right? Then we now have the last bit, which is a read write bit. So 8 bits is divided into a unique 7-bit address and the read write bit. Do you understand now? So if W is the right bit, okay, Daniel, you're asking the reason of your hand.
Please, I don't fully understand what the let's call it diagram is, and what is this diagram, and are you able to interpret it like the previous one that you were showing, and you were counting something on buses, and you were saying I don't know, like I don't understand it.
Okay, let me open the second picture so we can understand. Let's set this up. This one is okay. Can you see my screen now? Okay. Now, what I wanted to show you is this address frame. I wanted to show you in a much more cleaner way. That's why I brought this. You understand? So this is scattered. You were asking me questions, so it seems like you were confused on the way this was. So that's why I brought out one that looked more like a table to you, right? One that is much more organized than this. So now it starts with this start condition. The SDA will be low and the SCL is going to be high. That's to tell, that's the Arduino saying that, okay, I'm about to send a message, right? Now, when the Arduino sends a message, one thing you should know is every I2C device has a 7-bit, a unique 7-bit address. Now, your LCD is 0x20. Yesterday, we mentioned some other addresses that were possible that I used to ask a question at the end of the class. Mentioned 0x3f, 0x27, and some other address, if you remember, right? So I'm using the example of 0x20, but that's address that I talked about yesterday. That's the unique address that every different I2C LCD has. Now for this one that is 0x20, the unique 7-bit address is 0010000. Right? That's the 7-bit address. Then the address bit is 8-bit, right? If the unique address is 7 bits, the last bit there is to represent either a write or a read bit. You understand? So what I'm not trying to say is if this W, which is the last bit, if is 0, means write to device, and if it's R, that's this R here. If it's 1, means read to device, right? Do you get that now? Okay. Now, after the address is known, the Arduino is starting, so it's going to be able to get the address, right? After the address is known, so the Arduino sends data, yes, 8 bits at a time. That's every time it's sending, 8 bits at a time. I mean, the LCD must acknowledge each byte by pulling the SDA loop after the 8 bits. You know, it started with the SDA loop, SCLI. But you know, when we discussed in I think the very first class we had, when I was discussing theory, I made mention of I was using a sensor, that's DHT11 sensor. I mentioned that it starts with low, high, then oscillates back to and alternating like that, low, high, low, high, low, high. You understand what you remember, right? Do you remember? Okay. Now, it's the same case here because that, if you remember that last time, I mentioned the way the DHT11 works is different, but it works on the same principle. Low, high, then there's usually there's a little bit time that's the differences between the voltage and other things like that. Now the differences between the voltage is where the data is being transmitted. That's I think there was one that was 15 microseconds or something like that. But you get the point. So it's the same thing here. So when it's low, sends message. When it's high, it goes resets low, high, low, high, low, high. So, but in our case here, the SDA is the one that is starting with low. So that's where you see all this ones on top here. So that's to show that okay, this is I, this is I, this is I. But you get the point, right? Do you understand? Okay.
Please come again.
Now,
Sorry.
okay. So I made mention of the DHT11 in the first class we had. When I explained the theory, I think there should be pictures somewhere. The picture somewhere here. Seems like I don't have the picture. Okay, since I don't have the picture. So, but I don't know if I can still find it, but come on first. Let's see. Oh my, it's a beautiful black card. So, sorry, just want to get the picture so it's really easy to understand. So I can't find the picture. I don't think it's a Tinker card. That's a Tinker card. I think it's what. So I just want to show you the picture so it will be easy for you to understand.
I saw it on
The- It's not here. Oh, I've forgotten. This DT11 is not in Tinker card. But does anyone still remember the picture I'm talking about that I showed you? Does anyone still remember? Okay, okay, okay. So now it's good if you remember. So now in the picture, there was a voltage line. That's the pulse. Is it pulse? The voltage like that was going. It was going on a steady pace. That's spot. Then went dropped down. There was space in between. Then went back up. Space in between again. Dropped down. Space in between again. Went up and other things like that. So is the exact same case here. So, but now instead of us measuring by time, like we did, like measuring by 5 milliseconds, 8 milliseconds, like we did with the DST level, this time it is the SCL that does the measurement of that's synchronization. So now, because we are working with an LCD that pushes electricity through some crystals that makes them rotate several angles and other things like that. Everything has to be timed perfectly. That's why we have a separate line for the we have a separate clock line. So that helps with timing the crystal rotation and other things like that, so that everything you can get what you're actually looking for. So let me take it back. So, okay. So now for the SCL, that's this now. I don't think I have this picture. But for a 1 byte transfer, the SDA is going to be arranged in D7, D6, D5, D4, D3, D2, D1. So that's 7 bits. Then the D0, that's to check the read write, that's the acknowledge and other things like that. So now, when the 8-bit has been sent, the clock synchronization sets one that, oh, the LCD says, I got it. That's the Arduino. We are still discussing on that from the I2C communication protocol, how we actually work. So there's not going to be like, oh, why is it better than the 16 bits controls that the original LCD has? So now inside sorry, not inside, for the clock synchronization, the SCL is controlled by the Arduino, right? And it's running at 100 kilohertz or maybe 100 kilohertz, depending, that can run depending. The 400 kilohertz is the standard case, and the 400 is the fast case, that's the fast mode. So now That is about if you do a calculation, that's for the 100 kilo, that's 100,000 beats per second, and for the 400,000 kilo, that's the fast one, that's 400,000 beats per second. So now, when the message is being transferred, the clock synchronization throws the calculation and everything, then plus the timing and everything like that. There's a stop condition. So the stop condition is the opposite. That's when the Arduino releases the SDA from low. That's low is where we started from. So I, SCL is I. So LCL will drop back to low and other things like that. That tells that's the Arduino telling the LCD that, oh, this conversation is over. Is that clear? Or I should go over it again?
Sorry, please go over it again. I'm sorry. Thank you.
Okay, no problem. So, do you understand the part to the clock synchronization and all? Or is that way I should go over it? Okay, I understand that. So now, after the clock synchronization, everything that we just discussed is happening at an instant. It's not as slow as I'm speaking, as I'm making it out to be. Just trying to explain it. So now, when that happens within an instant, if you remember from DHT level, that voltage curve has to be set back. The one that started at low has to go to high, and the one that started at high, you get the point. So it's the exact same thing that happens. The SDA from low goes to high, while the SCL means that high, right? So that means that, okay, since it's starting at low and it's telling, and the low is the one that's telling the device that, okay, I'm starting to talk, and it goes back to high, means that the LCD is telling us that, okay, the SDA is telling us that the conversation is over. So all this happens within an instant. The start condition, the address frame, the acknowledgement that says, oh, the LCD says, oh, I've got this information as read right. The data bytes, that's the information contained within the byte as was transmitted. And our stop condition. That's I did not telling the we are taking that one. Is it clear now? All right. Now, one thing you should know is why all of this matters is means that multiple devices can actually share or make use of the same bus. You know what the bus is, right? Not the car. What bus in regards to electronics and embedded systems. Yeah? Do you all know what the bus is? Okay. So a bus is a connection point. That's how do I put it now? Okay, now. So for example, now let's say a review. Please, can you explain what you mean by a review would be nice? Is it a review of the course or whatever what I just spoke about? Okay. So now a bus. So a bus is like a connection point. I was looking for a way I can explain it that it's not going to be not going to be confusing. Okay. How can I say it? Okay, now, so think of a bus like this. Okay, you know what a bus is in real life, right? Bus is something that carries people from one place to another, right? But in embedded systems, a bus takes a predetermined route. Okay, for example, now, the bus, let's say a bus that going from Bega in Lagos directly to Oshodi. So now, the bus can take different kind of people. A farmer, a farmer, what they call it, a teacher, and other things like that. It can take different kinds of people from different walks of life, right? So now, the bus is a medium. We also transmit those people from point A Bega to point B, regardless of where else you are going to in HOD. It's the same way in embedded systems. So a bus is kind of a connection point that is used. It's a connection point. The connection point is like the bigger bus stop. It's a medium of communication, of transportation between different points, different components in the system. So in systems programming, we have the D-bus, that's the Daemon bus. The Daemon bus is the part that makes sure the display can communicate with the graphics engine and that is like that. So it's the exact same way. So the bus is like this kind of communication layer. So the bus can take the communication, the information that several components need and transmit it all at once. Because you know the normal bus can, in the example I gave, the normal bus can take different kind of people. So it's the same thing. Bus can take information from the sensor, so the one from the LCD and other things like that, and transmit them straight to the Arduino on the same transport lane, same memory lane, or whatever lane it is that they're using for communication. Is it clear? Was I able to explain it clearly? Okay. It's good to hear. So sorry sorry if the explanation was a little bit here and there. I'm just trying to like break it down so it's going to be easy to understand. So now back to what we're saying. So now, as I said, different components can communicate using the different bus, right? Sorry, using the same bus. It's the exact same here. It's the exact same thing here because multiple devices can share the same bus. I2C enables LCD to also be able to share the same bus as multiple devices because it makes sure that multiple LCDs has different address block. Is that clear? Is that clear? Or I should repeat it. Okay. Sorry, I'm going to admit this person. Okay. So what I said before was because multiple device, the I2C, because the way the I2C is designed, because of the way it's designed, it can let multiple device, that's multiple device from the multiple LCD devices share the same bus because they have different 7-bit, unique different 7-bit addresses. That's they have each of the devices, that's each of the LCDs are going to connect using the same bus, have a different address. So it means that device A, LCD A will not interfere with LCD B, and LCD B will not interfere with LCD C, and so on, and so on, and so on, and so on like that. Exactly. Okay. So I see. Okay. Now, another. Okay. Someone said it's not clear. Okay. So, with the explanation of a bus, right, that I explained before, the explanation of a bus, you know, a bus can take multiple components and take the data of multiple components, take it on the same transport lane, and still deliver the data to the necessary places where they need to go, right? So now, if you now take that analogy, now put it in this case, an I2C, the I2C protocol in LCD lets multiple LCDs be able to communicate on the same bus because each of the I2C gives each of the LCDs a different address. That's a unique address. And when I mentioned address, I mentioned about the 7-bit unique address, like the last either read or write address, 8-bit. You understand, right? You understand that part? So the I2C protocol lets LCDs, different LCDs, multiple LCDs, be able to connect and talk to each other on the same bus If we're using the old LCDs that has a 16 pin, it won't be able to work that way because of the way that is. But with the advent, with the bringing of the I2C communication protocol, enables multiple devices, multiple LCDs to communicate or use the same bus at a time. You get, I think it's Israel, DVC that said you didn't understand. Is it clear now? Okay, okay now. So another advantage of the I2C is no matter how many devices you want to connect or how many pins you want to connect with the LCD, you need only 2 wires. That's for the SDA and for the FCL. Now I know everybody can the advantage of the I2C communication protocol. Instead of it to be connecting 16 pins, I think let me show you so I can.
Your screen is not showing.
Okay, is it showing now? Okay, I think it's
Yes.
showing now. Okay, so instead of you to work with all 16 pins on normal day, because if without the I2C, this is the I2C protocol connection point. Without the I2C, you're on normal day. These are the pins I'm going to work with to actually control the LCD. So instead of you to use all these pins to control the LCD, the I2C protocol lets you use the SDA and SCL pins from able to control all parts of the LCD, so that it will be working for the 16 months. Is that clear? Okay, seems like that is clear. Now, another thing I want to explain because it's going to be useful for your assignments. I'm going to give you. The assignment I'm going to give you is going to take you between 2 to 3 weeks, sha. So now the LCD, that's the LCD. What I want to talk about is how the LCD generates characters. That's that 5x8 matrix I talked about. For those that were not here yesterday, when I explained the way LCDs worked, I explained the way each of them generates characters. So what I mean by the 5x8 matrix is this is 5x8. Is that clear? Like, do you guys understand what the 5x8 matrix is? 5 pixels to the 5 pixels on the top, and 5 pixels 8. So that's making it 40 pixels per grid. Yes. Now, so what I want to explain is how this generates characters. So now, the first thing I want to talk about is called character memory. So the LCD has a built-in ROM containing about 256 pre-made characters as letters, numbers, and symbols that it can show, right? So it's since those ones are in bytes, the memory is very, very tiny. Now, so when you print the letter A, you are telling the LCD that display character 65 from the available memory. So now, what this means is on the 5x8, this 5x8 pixel grid, each character position is 5 columns, 8 rows. That's 40 pixels, as I explained before. Now, for letter A, what it means, because it's going to be converting it to binary. So it means that, okay, in row A, you should put the binary 0110. No, sorry, 01110. That's for row. I'm just giving an example. Let me take a picture. This picture of it best for this. Okay. Sorry, I'm trying to like just get a picture. Okay, let's go back to our this thing. So okay, this all right. Okay, so now for the letter A in binary, right? For the letter A in binary, what we are trying to do is to present each of these letters, each of these binary on the rows in the 5 by 8 grid. So now it's not compulsory you know what the binaries are, but I just want to give an explanation because it's going to actually help you. So when you know what how to identify, so how to code in different how to code in a binary like different letters in the 5 by 8 matrix, you'll be able to create your own custom characters that are not available in the ROM. You know, the ROM only contains about 256 characters. So for the letter A, this is the address. So you can always find the addresses online, right? So there are other people that will have done it. So this for the letter A. So for row O, the same things for row 1, 2, 3, till you reach the 8 rows. So as you can see, this 1, 2, 3, 4, 5. 5, 8. Exactly. Okay. So for a custom character, let's say you're trying to create like this is for art. That's the symbol of art. That's what the is. So this is for the symbol of art. So this is for the two bumps. So the two bumps are going to be on the second row because this one is started. Then for the full width, that's at the edges. Then this one's also at the edge. Then the tapers down. That's the 12, then 12, then the one that is ending at the center point. You can, if you look very closely, you can see that the number ones almost form an arc. Sorry, a arc goes like this, like this, like this, and form like this, like this. You can see it, right? So your only problem is because of the letter A is already saved inside the ROM. You only need to follow the same principle because you know there are 256 characters already saved in it. You just have to look for the correct number that each character is associated to. But for you to create custom ones, you have to go through the stress of doing all these things and other things like that. Because you know, each of these letters represents. Because if you remember yesterday, I mentioned that the way the crystals work is they rotate, so either let light pass through them or light not pass through them. And 0 means okay, light's not passing through. 1 means light is passing through. So when that, if you use the same analogy, you can see that okay, saying that okay, this is dark, this is there's light here, this is dark, this is there's light here, there's light all around here, there's light all around here, this is dark. You get the point, right? You should get it now. Oh, any questions on it? Okay, no questions on it. Let's get back to our thing like that. So now that is the way you do custom characters in that's the way you do custom characters in using LCD. All right. So now I want to explain the LCD's memory architecture. So after that explanation, then I think we to go to this thing, the practical class. Now, the LCD has 3 types of memory. There's the DDRAM, that's split data RAM. So that's the memory that stores what is currently being displayed. It is 80 bytes in total. yeah, 80 bytes in total, but only 32 is visible. That's 16 by 2. That's 16 rows across. So 16 rows across. So 16 characters across 2 rows. Across 2 rows, that's 32. Then the address for the DT RAM is usually 0x00 0x0f for row 0, and for row 1. So this is 0, this is 1. So for row 1 is usually 0x40, I think 0x4f. That's 1. So, and their addresses was true truly. It's not supposed to be on really know what I'm trying to explain. Just trying to like not really not know. Like it's not supposed to save it in your head and other things like that. Because I'll just explain how the array works and other things like that. So it won't be you won't be eluded if another person is talking about it. So for the scrolling, no, there's scrolling. We're going to work with that here. So for the scrolling, is between memory address 0x10, I think 0x27, and 0x50, I think 0x67. So now that's for the first type of RAM. Second one is the CG-ROM. No, the first one I talked about was RAM. This one is CG-ROM. I'm talking about three different types of memory that the LCD has. So the CG-ROM, mind my kata, please. Sorry, don't mind. Please don't mind my kata. The CG-ROM, that's the character generator room, has permanent storage of 256 standard characters. So you can't change it. You can't add to it. You can't add to it. You can't minus from it. So that's CG-ROM. It's just for the characters that are saved on the LCD. Remember I mentioned that. Then there's the CG-RAM. So this one is 64 bytes. It can only generate it has 8 characters. It can only store 8 characters, custom characters. To the 0x07, that's accessible via the lcd.create character what do you call it? That's the command to create custom characters. So since we are done with the theory, we're going to go to the practical. So today is different from yesterday. This what I gave yesterday, I think, was simpler than this, something like that. Okay, so today we'll be creating a multi-screen display system. Now, when I'm saying multi-screen, I don't mean 2 LCD, 2 LCD. No, when I first ran this is a screen, right? So yeah, sorry. This is a screen, right? This is a screen. This is showing only one thing. So if I want to change this screen to show another set of information, like when I'm changing channels, that's another screen. I'm changing. So without erasing the previous ones from being able to show, that's another screen. So that's a multi-screen system that I'm talking about. Now, the code is much, so that's why I was asking Princess if we are going to we're going to spend more than 2 hours together. But if we can write it together, what we're going to do is I'm just going to put the code. I've already put it there. That's why it's going. I'm going to show you the code. I'm going to explain line by line. That should be simpler to do. Okay, now. So now, what are we building? We are building a system that tells you distance, temperature using an LCD. Right. So when I was trying to build this, I was thinking of what can I actually build that actually be able to cover a lot of things because it's good. It's just possible to introduce you to a lot of new things. So now we're building multi-sensor display system. So these are the things you find in new products, but they are more complex than this. So able to display multiple screens of information, button navigation, live sensor data, and statistics tracking. So if you're able to replicate this, 'cause I'll also share the code, but if you're able to replicate this, you have a portfolio worthy project. That's a project that can put in your portfolio. I'm like, oh, you're like, this person is cool, this person knows what he or she is doing. So, without further ado, I really don't want to do this thing again one by one, but okay, let's see. So, I want to take a vote now. So, raise your hand if you want me to restart building this from the beginning. Like, I should clear this off and we should start from a blank state. And leave your hands down if you want me to just explain what we have on the screen. Do you understand what I mean? Okay. So, Promise, Daniel, Israel, are you raising up your hands? Right. Accountant. Okay, it's like they are not raising their hands. Okay, so I'm not going to clear it. So I'll try my best to satisfy both worlds. So let's get right into it. So due to popular demand, it's the ones of not clearing the hands. Let me start with first. Now, so this is what we're going to do. I'm going to look like you're going to start with a blank state split at the side. Okay, so say we're starting with our Arduino, right? That's the name of every project. Then your normal breadboard. You can use a big, you can use small, but I prefer this small. So it gives me flexibility. Okay, so we have these two, right? Can you all hear me, right? And you can see it very clearly. Can I get a thumbs up? Okay, thank you. So now we have this. So what are components we actually need for this project? We have Arduino, and Arduino, we have breadboard. That's we have a sensor. That's the sensor we discussed in the class before the last class, and we have a temperature sensor. Then last but not least, our push button. So have you guys actually done push button? Let's see if there's done push buttons. No thumbs up. Okay, so push button is exactly as it sounds. A button to like just push to change things. Right. So now, first of all, the thing to do with every project you want to build is to design the architecture. So the architecture is okay when you connect everything. How is the system going to run? What part are run first? How is the flow? How is the information going to flow from each component to the other? How is the information processed and other things like that? Now, for this project right here, this very beautiful project, the architecture is we have the sensors first, then sensors data. This data from the sensors get processed, then they get sent to stats. I won't call it starting, but stats will do. Then the screen manager, then so display, right? So that's the way the information process goes from. So from our sensors to the data processing layer to the statistics layer, then our screen manager, that's what that switches to the camera, like that. So now, what this architecture explains is it explains modular programming. It means each function has one job and makes let's say debugging your system and debugging whatever code you put to it, whatever code you write to the architecture, makes it very easy. Now, because the code is much, I will show you. So, but before I show you, we have to do a connection. So now let's start with our breadboard. So we all know that our breadboard to get the power rails from both ends connected, just connect them from here to here to here. That's, we have ground to ground, and so one thing you guys might have noticed in this one is I've always been someone that preaches about cable management, but this cable is not managed. Please forgive me. It's because when I was trying to get this thing to work, it was frustrating my life. If you can see from this bottom, cable was getting managed first. When I go to this place, it was just giving me problems. So just scattered everything, trying to debug and other things like that. So we have changed our ground rules to black. Was ground is always signified by black, then our power rails by red. Power rails get connected to each other like the way you what's it called? Okay. Then we change it to red as to signify power. So as you can see, that's what I think here. So sorry. All right, here and here. So it's the same thing. So then we now connect our ground to Arduino and our power to our 5 volts of Arduino. So that's what we have here. That's what we have here. And yeah. See, ground power connected to 5 volts and our ground on our Arduino board. Now, when we've done that, connect our sensors. So temperature sensor goes onto our board.
Sorry,
Yes.
sorry, please. What did you say we were going to connect the ground to?
Okay, so you connect the ground to your ground on your board. You can see it, right? So your Arduino board has the 5 volts. That's what you connect power to. Then it has a ground. That's what you connect ground to. But it's the reason why ground is ground anywhere. So actually that's black, so it's going to be easy to recognize. So you'll be able to know the difference between power and ground. This ground, I think if you put it here, should even show you. It's not sure, but this is ground. Now, you all remember the way we connected our temperature sensor the last time. So power, the left power will go to our power rail. Then our ground will go to our ground rail. To our ground rail, change color to black for easy identification. Then our V out starts our voltage out. Voltage out connect to our analog. When we connect to our analog 0 relay on our Arduino, right? So I'll change this color to whatever color you want, apart from black. So make it green. Last class. That's how you connect your temperature sensor. So for our ultrasonic sensor, it's also simple to do. The ultrasonic distance sensor, bring this here. In that space, connect it. So now the only difference between this and the temperature sensor is we still have the same power. Power is connected to power. How to connect to power, change to red. Yeah, ground is going to connect to ground. This is black. Then our trigger now since this you communicate using digital pins. So that's a trigger. That's for the left side of the what do you call it? Of the for the sensor. Goes to 12. You can put any color you want. I think put yellow. Then the echo, that's the other part, is the part that receives whatever is trigger says. Goes to see. So is that what I did? Yes, that's what it is. So it can be different, but because of the code I'm using, that's right. Go like that. So don't mind the people saying that they're pressing each other. Then the LCD. So that one is also not tricky. Now, when you're getting your LCD, I explained that there's a normal LCD and there's the IC2 LCD. So make sure you get the IC2 LCD, because if you just search for LCD, it's going to give you the normal one, which you have to start trying to connect 16 pins. And nobody uses that nowadays. So take our LCD, let me zoom in to ground, goes to ground, change the color to black, then power, not so red, then our, because of my code, but they all connect to analog. So STA goes to analog 4, changes to purple or green or orange or purple. Then our SCL. So okay, this connects to analog 5. So connection secure. Then our push button. Push button. Push button. This is a foreign bastard. So since on normal day, if you were to use a push button, you're supposed to use it with a transistor, but with a resistor, right? So uh, as I did with the what do you call it, with the light LED for those that were in the previous class. That's the class we had last week. So remember, I connected LED with the transistor with the resistor. But you can do that. It's optional here because Arduino has an internal resistor that you can you can use if you know the key for it. That's the code. So the name of the function is called input underscore pull up. That's the function that can act as a resistor for the button. You get exactly. Okay, it's clear. So now for our button, our push button, it's going to be diagonal. So I want to see the way I arrange it here. So terminal A1 thing, okay, goes to ground, change that to black. Then the other diagonal, terminal 2D. This one is going to connect to 2. Let's digital pin. So each one. So and change the color to the plot. Okay, so for because let's say because we want to allow to actually run this. So I think this will do. Take our power reels. This no, no, that's no. 5 volts. Signature red. Yeah. And this round, no 5 round. Any colors black. Okay, so for class poses, I forgot. This idea. This yeah. Okay, so let me think if you complete like this. Yes. Yes, let me delete this one. Yeah. Should by God's grace it should work because it's the same thing. So if it does not work, we start around the debugging. So because the code is already there and we use the same connection, it should work. Now it's not working. We have to look at what we did wrong. Okay, sorry about the kata. Okay. Okay. So let's this. Okay. And this. Okay, let's try it again to see if it works. It's not working. So let's look for what the problem is. Check. Disconnected ground to correctly. A zero. Ground. Sorry, I trying to get this. So see the way the connections work. Okay. Okay, let's check. Yes, 32. Everything seems to be correct. Okay. Oh, the code is not there. I saw it was wrong. Let me concentrate. Sorry, trying to play the code. Um, sorry, I'm trying to like get the code. Sorry. Yes, sorry. Okay. 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 So our system works. So all right. Okay. Want to see the temperature is reading correctly. Okay, temperature is reading correctly. It's just very slow. I think what I'll do is I'll reduce. It's just very slow. It's just very slow. So let's see which button works. Okay. Okay, so which button works? Let's close screen. Okay. Now, since do you all understood the way I connected everything, even though it's not looking for anymore? Okay, any questions on the connection before we go to the code? Because code is the most complicated part of this entire thing that we're only right here. Any questions? I want to know because as you can see, the code is very much. So that's why I said we won't be able to like write it together. So I'll just paste it and I will explain line by line. Okay, I'll take it as no questions there. So it's time to go to the next part on our agenda. That is part that takes all this and make it work the way we want it to. That's our code. For those that were in class yesterday, I talked about Tinkercad having preview libraries for all of their components. Right. So by the way, you might have to check the docs to know which libraries for which component and other things like that. Because if you try to randomly guess, it won't work. So we'll consider now. So for those that were yesterday, I explained some parts of the code of getting our LCD working. One of it was initializing our LCD. So that's address 0. So if you're not using Tinkercad, it's obvious that your LCD is going to be on a different address. That's where the remember I explained when I was explaining the I2C communication protocol. I mentioned about unique addresses. The one we talked about or explained was 0x20. That's the address that we explained. I think you can see this was the address we explained. That's we talked about that 01000000. I think. So we have different addresses. So different LCDs have different addresses. So those addresses means that inside this communication protocol, if I want to talk to address 0 or 1 and LCD 1 at the same time, I'll just pull one address. Do you get that? And let's say it comes with this. You understood that. Okay, you understand. Okay. So when you want to initialize your LCD, that's the way you want to start your LCD, not really start, but when you want to get your LCD ready, when you want to let your attendant know which LCD it needs to talk to, right? We made mention that the LCD, the I2C, gives every LCD a different address, the unique 7-bit address plus the last read or write bits that makes it 8 bits. But that 7-bit address is different for each LCD. So because in Tinkercad, you can change it to whatever I want, but the default is 0x20. Remember, I explained the 0x20 address. That's where I showed you that table, and I showed you that 7 bits. Look, it's a 7 bit. When you convert 0x20 to binary, that 7 bits is at 01. I think 001 or something like that. 001 0000. If you remember correctly, that's 7 bits address. Now, that's the address for 0x20. Now, the address for 0x27 will be different from the address of 0x20. Address for 0x20 and 0x27 will be different from the address of 0x24, and like that. Now, because we are using Tinkercad, we don't have to specify the address that the LCD uses, because Tinkercad just gives us the default. That's why we can use 0. But if we're to be writing normal code, we're going to specify the address that we are using. And if we are communicating with multiple, if we are using multiple LCD, you specify the other addresses that you're going to be communicating with. You get? Now, the reason why we can communicate with 2 LCD and specify 2 addresses is because the I2C protocol lets multiple devices communicate on the same bus without any problems. Is that clear now? So, who didn't understand earlier? Can I say thumbs up? It's clear. All right. So then go to the next one. For since the first class we heard, we had made mention of constant as global variables. So we're going to be using that to define the things that each of our connections are in. So the tree, that's the trigger pin. Which trigger pin? Let's see. So the trigger pin. I'm just against the specific. Okay. So for a trigger pin, so that's connected to pin 12, so is the echo. So every pin that each of your devices are connected to, you have to specify the here. Not clear? Okay, it's clear. Now, the next thing we have to mention is the screen screen state. No, I made mention that we're creating a multi-screen space system. So, and since we are starting with 0, I wanted to start with 0. As you can see in the comments, the screen state for 0 is distance. As you can see in the example I showed when I ran it. The first one was distance. When I change it to, when I use the push button to change it to temperature, and when I use it, push button to change it again to show stats. Now, so then last button state, that's the state of which push button is always in. That's last button state at the top, button state and other things like that. Get that. So all of these are just variables that we are putting in place. We are able to use them in the code in some other time. So now, the difference between variables that have CONCTS, this in them is these ones are variables that no matter what happens in your code, they can never be overridden or changed. Get so the our trigger pin, that's the definition for our trigger pin, would always be 12. there's no part in the code that we want it to be 13 or we want it to be 14 or we want it to be 9. So it's going to be the same. So outside Arduino now, it's also the same thing. If you're writing a code and because you know the correct the solution for pi will always be 22/7. We use the constant variable definition for it because you know no matter what happens in your project that you're building, your code that you're writing, pi will never change. We use the constant. So it's the exact same thing right here. But these are things that they can change. So that's why we're not using constant. These are variables that can change. That minimum distance can change, maximum distance can change, total distance can change, reading count can change, average distance can change. We all want them to change. That's why it's not going to happen. That's why it's not going to change. You get exactly. Okay, I take that as clear. Now, the reason why I explained the way to use custom symbols in LCD is because of this. So we're using a custom symbol, the degree sign that's around the degree sign. Now, as you can see, it's not the degree symbol is not part of the 206 symbols that are stored in the LCD's memory. So we have to create it. And if you remember, these are the rows, then these are the 5 grids. That's one. These are the 5. This 1, 2, 3, 4, 5. And if you can see the drawing, you can see that this is the 2 on top that I want here. This is the 1, 2 that I want on the side. This number 1, 2 are the 2 that I want at the bottom, and this are the number 1, 1 that I want at the side. Is that clear now? It's the way you draw the binary clear. Can I say thumbs up, please? If it's clear. Okay. So as I explained before, because one blocks lights, one switch on lets the light pass for another thing like that. So that's why we are able to get this. So if you can picture the signal you want, the symbol you want to draw, and just even if it's smiley face and all that things like that. That's the way it works. But it must just fit between your 5x8 grid system for the pixels to be exact. Now, the void setup, as I explained, I explained that last class and one before that. That's what last week. Void setup is setting up your what do you call it, your code. That's like your main entry point. So we start with the serial begin. So this anything that you see serial in front of it, that means it's to be printed on the serial monitor. Anything you see LCD in front of it is to be printed on the LCD. Is that clear? Okay, I think that was clear. So on the serial, we start our serial monitor, then print the multi-screen screen starting, like what you saw earlier. Then on our LCD, you switch it on as you start all the what do you call it? Start all the rows and columns. You start all the rows and columns. Then you set our backlight as 1. That's switch it on. That's light that first turns on. Let's see. We turn this on. Right, so the first light that first turn on, as you can see, that is our backlight before every other thing started working. That's our backlight. Stop that. Now, let's go to code. Now, what we want to do is, I talked about memory. That's the CG ROM. That's a character generation ROM. That's the one that lets you stores the custom character you created. And it takes 8 characters, 8 bytes, that's taking a total of 64 bytes. So, and I said that you can create and load it using the LCD.create character function. So, because our function was created and stored using a variable, we call that variable the start. This is the starting point. Then call the variable. So then to display our splash screen, you clear. As I explained in the last class, you must always clear the LCD because it's not really clear it here. You must clear it. And you set cursor, that's where you want it to start. That's you want it to start from row 0, column 0. Then you want it to print multi-screen. Then set it to row 1. Sorry, column 0, row 1. That's the second print system viewer. Let's run our simulation. See, you can see. Started here, printed it out. Then when that was done, started at the second place and print out the other one. So then we have the delay, then the clearing of the screen. Then, so we have to set up our sensor pins. So that's the pin, already defined them. We're just calling out the, what do you call it? The variables that we've created. Another thing we are doing is with our button pin, our push button pin. Now I told you that we could use Arduino's internal resistor to run to work with our button with our push button instead of adding resistor. You have to call it, because if you don't call it, it's going to fry up your pin and that is like that. So you must always call it if you're going to use a physical resistor. So always encourage people to use a physical resistor. But unity resistor can still cause problems in its own right. So it's better to just call it in code. So do you understand what I explained about the internal resistor now? Okay. So then we print to our serial monitor again. Then a loop. I explained what loops were. Now we want this to always happen. That's why this is a while loop. We want this to always happen. That's why we are running to a loop. So to read our this is going to take the result from our alternate sensor and read it and see if it's a distance variable, same the temperature, so we update statistics. So this is the statistics in our case. This here is the statistics, as you can see. So when you read everything, so it's displayed in serial output, not to display in serial output. That's where the print screen, then screen. We're going to print the screen. We want it to print the current screen. That's the variable that we set from the top. Distance, that's current distance that's there. Then we want it to print single temperature, other things like that. We want it to print the degrees. Then want it to update 5 times per second. Then if we want it to update more times, use the delay and other things like that. Like, okay, I think that everybody understands that part. Now, to the next part of our code, the sensor functions. Now, here we're going to read our what is it? The result from our sensor, right? Let's read the result from our sensor, and we're going to write it. If you keep remember, I was explaining the voltage, that voltage band. I mentioned starting with low, and that's what Arduino likes to start with. Starts with low. Then there's a certain amount of time in width in microseconds. I think the one for the DHT11 was 50. Let's say, sorry. One for the DHT11 was 50. The LCD doesn't have like a specific time range because that is controlled by the SCR as a clock, the clock light. So this slow, then goes to high, then it goes back to low, and that. You understand what I mean now? If you as you see this, do you understand? My thumbs up. Okay, thank you. Then you read the duration of the eye to need to calculate distance. So this is. Well, I explained this a class about what it looks in a class about Musilulua, see your hand raised up. Do you have a question?
Yeah, I think someone had it thumbs down when you asked if we were following.
Oh, please, who is that? I didn't see it. Okay, promise. What's my okay? And Daniel. So you guys can ask your question first.
The part for that serial monitor, I didn't really get it.
Okay. So what exactly don't you get in the serial monitor? Is it the way we make it print to the serial monitor, or this part? This part. Promise. Promise, are you with me? Okay. I'm asking what part is it on is unclear? Is it this the part the code that prints directly to the serial monitor, or this general
Yes,
loop
yes, yes.
function?
This part.
Okay.
Yes.
So
Yes, this one is just selected now.
okay, this loop. All right. So let me explain the loop. So I already explained what loops were in one of our class when we're dealing with for loops and while loops. So this is a while loop. Now, what this loop is doing is going to update what it update the thing that was only printed in the serial monitor with the information every time it gets updated, right? And because the serial monitor, you can see that no matter what happens, the serial monitor is still printing on the screen. It is because the loop is in effect, meaning that it's no matter what happens, it is always looking for, the loop is always checking for whatever it needs to always do it. Now, what our loop actually now does in our case is it reads information from the variables that we set. Now, the variables that we set are variables that we set in this case, that's real distance. Now, this variable distance is getting the information from read ultrasonic. Read ultrasonic is another variable that was created to always read the results of the ultrasonic sensor, if that's clear. So it's always going to read the distance that the ultrasonic sensor is sending. The result that the ultrasonic sensor is sending every single time is being stored in the read ultrasonic variable. Now, we're not taking what is being stored in the real ultrasonic variable and now saving it in another variable called distance. So we'll be able to call the distance variable later on. It's the same thing that's happening with temperature. The temperature that's being measured every time is saving the result of the temperature to the read temperature variable. And that the read temperature variable is now saving it, that same result to the temperature variable. Now, what is now happening is we now want to create a function that updates the statistics. So it's now going to update distance as the distance and other things like that. So now when it does that, it checks for the button press, this button press, and when that happens, it displays the appropriate current screen, either distance or temperature. Do you understand? Okay. Now, when that happens, it prints the output to the serial monitor. Now, the delay is how many times we want it to show per second. That's if we want it to show more times per second, we reduce the time that it delays for. But if we want to sorry, that's if we want to increase the amount of times it shows per second, we reduce the delay, that's the amount of time it waits for. And if we want to reduce the times per second, we increase the delay, the amount of time it waits for. So what I'm not explaining is the what do you call it? The sensor functions. That's the way they work. I've already explained the way this works in our previous class when we discussed about two sensors in particular. So now, if you remember, I said that the result of whatever the ultrasonic sensor is being sent is getting being saved to our read ultrasonic variable. So You might be wondering, why is this code after this the part that is being called? Well, unlike Python, that you have to arrange your code the way you want it to be because it's an interpreted language. The interpreter reads it line by line. For C++, the language gets compiled into machine code once and for all, meaning that it doesn't really look line by line, just compiles everything at the same time and just runs it. You get? So that's why we can put this down, still call it at the top and other things like that. So this is the calculation of this is the code that creates the calculation of how I was able to calculate what distance is, what kind of distance, and this is the same thing for temperature. I've explained it in the previous classes that we had about sensors. If you don't get it, you can go and watch it. So for the statistics, this is the statistics. So distance, if it's less than the minimum distance, it's the minimum distance, it's the distance, and that things like that. With the maximum distance. You remember we said the maximum distance, but we said we didn't count also 0. So the average distance. So this is for the third screen. Remember, there's a third screen. So the statistics is what it's going to show. Right? So now the button functions. So button state is the current button state, which is going to be 0, obviously. So or whatever it is, I think it's 0. It's either high or low or whatever it is. So when button changes from high to low, this takes it. So that if button state is equals to low, instead of putting 1 equals, you have to put 2 because that's the condition. That's 2 is close to low, and this one is also put 2 to the back. This is not English language. And the last button state, that's the previous button state is equals to high. So this is like the equals to high. The current screen will change by 1. The plus is an increment. And if the current screen is greater than 2, that's if it's greater than 2, no, it's 0, 1, 2. If it's greater than 2. Like when we press it, it's which is between 1, 2, 3. So if we press it again, instead of it to go to a 3, this code, this function here, make sure it goes back to the current screen, that's the first screen, which is 0. You can understand me. Then it clears the LCD. Like I said, it was always clear the LCD. Then our this thing gets updated, our serial monitor gets updated. Then display function as the display temperature, display statistics, all that things like that. So you can see LCD sets cursor to set the photo, then it displays it, the same thing out of range. But if the out of range is if you move it outside the range, that it can place in the temperature and statistics spread. So as you can see, I think it's here. It's in the temperature. So we call our custom what they call it, a custom degree symbol that we created and other things like that. So let me show you. Okay, switch screen, temperature. So that's our second screen. Temperature, displays our temperature. Then we have our custom symbol before we see, as you can see. Then same thing with the last screen. Sorry, I'm pressing many times. If there's you delay this too much, and it's not always need to explain fast enough. So I'm giving it my project. So you can see the calculation, that's the statistics that we did. This calculation is this one. That's the minimum distance that we saw, maximum distance that we saw, the average distance that we saw, and our total, I think This is the number of times of calculated. Yes, that's 15. It's very quickly in whether it's 16 and things like that. So, any questions? Any question? Okay, no question. Mr. From said there's no question. So I think it's time I ask my own question for some price.
Yeah.
Okay, it's real. You have a question.
Is it on the ultrasonic sensor? Like, where is it reading the distance from?
Okay, it seems like you were knowing the other class I explained it. So the ultrasonic sensor, as the way it works is this first part pushes out sound waves. So when it pushes out sound waves, the sound waves goes about and bounces of different different materials or different objects and gets received back in this part, this second part. So because this is not physical, we're able to manage it by arranging it using this linear to simulate the same effect of an object standing within the range. So when it sends out the signal, it sends it out in the cone shape. So like this is a visualization of the way the waves have been sent out. So if an object is here, bounces off this and gets received back by this other part. That's when it's able to measure the time that it takes from this to reach to come back. You understand what I mean, right? So it measures the time it takes for it to hit one object to another. So and the code to it does not do it automatically. You're the one that do it so you can say distance equals to duration multiplied by the speed of sound divided by 2. Speed of sound is 343. Well, because we're not using the exact like thing, but you get the point now. Because this is our time of that is that. So that's right. All this that's what is for these calculations are. It's just to make sure we're able to get the distance correctly. But any other questions?
Sorry, I was in the class yesterday, although I understand the ultrasonic sensor now. But it will mean like how does the temperature sensor so?
Okay. So the temperature sensor has what I would like to understand now. It has uses what do you know this thing? I think something T resistant something casing or something like that. I've forgotten what we call it. So what it does is it checks the differences between there's this I forgot the way it works. How can I explain it now? I think what I'll do is I think is in the notes I sent to the class. I've forgotten the exact. There's this exact word we call it. There's this acronym. This RCT or something. Can anybody help me out, please? If does anybody remember what it is? I've forgotten the exact thing we call it. But okay, say reactive something sharp. So that's that particular thing. I've forgotten the name. It's kind of has electrodes in it that helps in checking the differences between temperature in and out and other things like that. It's also the same way the DHT11 checks for temperature. I've forgotten the exact name. It uses this thing. It's this casing that uses. I've forgotten the name. I'll send the note again to the class. The note contains how the temperature sensor is. I'm very sure I'm able to answer you in this class. Very clearly, sorry. I've forgotten it. So if I remember before or I need to let's review. So any other questions? Okay. I can see we have 0 questions. And
Sorry,
okay.
I just want to ask about that temperature. Like in a reward something now, is it going to measure the temperature of the environment or the components?
No, the temperature of the environment.
Okay, okay.
Yes. So, in the absence of any question, I think I'm going to bring the bell. So I'm going to do the exact same thing I did yesterday. I'm going to ask a question, and anybody that gets it correctly, take my 2K. So I've already named the person that won it yesterday, or the person carry my money again. So who is going to carry my money for today? So let's see, what person can I ask? What person can I ask? What person can I ask? Okay, yes. This one is a simple question compared to yesterday's question that was difficult. So I mentioned when I was explaining the way the I to C communication works, I mentioned 8 bit full address, then 7 bit unique address, then the last bit that does something between. I think I'm not going to say this something because if I say this something gives up the question. So the last bit usually change to do 2 things. So what does it change to, and what are the things the last bit represents? Okay, Israel.
Yeah, the last memory can when it change to 0, it can change the W, it can either change to 0 or 1. That means it can read from a device or write to a device. That's my
Mm,
answer. Hello?
okay. Yeah, you did get it, or you did not get it fully correct. So, and Israel and DBC already mentioned read or write before you were able to talk. Maybe what I'll do is I'll divide the prize money into 2, so that is the first Israel will take one and Israel Square will take the other one. If that's okay with both of you. Okay. So what I actually wanted you to say, Israel blessing, say was W, when W is equals to 0, it means it's time to write, and when W is equals to 1, it means it's time to read. You just mentioned it abstractly without really mentioning the exact what exact bytes represents. But you get that, right? Okay, so I don't know, should we do the transfer now? You send your account number now, or you send it on the group chat? Which one? Please let's decide to leave and good things. Yes, so there are 2 Israels. There are 2 Israels.
Okay, you mean the two of us should send now?
Yes, or you don't want to share?
Okay, okay. I'll send.
Okay, yes. And also for the person that did the assignment correctly, I have 5,000 naira for you. So who was it again? I think it was Israel. Was it Israel? Oh yes, Israel. So Israel, I'm only 6,000 naira. Send me your account number. So, will you guys send it on the group so that end our class for today? It's very nice having you guys with me. I'm sure you guys understood what I taught, and we're going to be here next week on a different topic. Okay, we're going to be dealing with another topic. Okay, yes, your assignment. Yes, your assignment. This time, because the assignment is big, it's going to take you guys 2 weeks to do. Maybe I'll send it on the group. It's going to take you guys 2 weeks to do it. And this time, the prize money is I I don't know how much I should put there, but what's his speed? It's not going to be 5,000 rally. Let's see. How much would it be? How much would it be? How much would it be? How much do you guys think the price money should be? Because it's a 2 to 3 weeks assignment. It wouldn't be something like the 15K. Yeah. 15K, let's say 15K. 25. Let's find the average for that. 15K it is. So the price money is going to be 15K. So has everybody agreed with 15K? Okay. This person that is adding 20. Okay, used to people really do speed 10K. Well, there's no problem with that. We can also do that also. Also do that. There's no problem with that. Think people can split your shares. Split your price. Okay. Other place. So first blessing, IDBC, I've sent it. You should have received it by now. Yeah, no problem. So just do your assignments and make sure you're able to answer questions and always get a prize. So that will be all for today's class. And also second blessing, second Israel, I'll send you on to. So in the spirit of post Valentine, even though none of you sent me gift or invited me, I wish you guys a very blessed week, and we'll see next week. I'll send you your assignments. I'll send you assignments in the group chat. So, and this time, just so you know, I'm not providing code like the last time. You guys will have to write your code yourself. And if you are lucky, if you are able to get AI to help you write it, not that I will encourage you, to get AI to write it for you. But it's a plus, but I will know. So, because AI will use some jargons. Yes, you're saying something.
Are you going to share the assignments in the group?
Yes, I'm going to send it on the group.
And when is the deadline?
I'm thinking 3 weeks. I'm thinking 3 weeks might be too long, because in the next 3 weeks we should be finished with all our classes, because we only have one more topic. That's what we'll treat next
That
week.
means after the assignment, you are going to share the source code, everything with you.
Yes.
Okay.
Yeah. So I'm also going to send you a new material next week. So I sent one, and I apologize for it being 30 pages. I just wanted to explain in general. I know you guys were busy. Some of you have assigned and rest of that. So very sorry it was 30 pages, but I just wanted it to be in-depth enough and simple enough that when you read it, you'll be able to understand very easily, better than any other material that you might actually find online. So yeah, the assignment will be 3 weeks. And next week I'm going to add another one to it. So that's going to be your final project. And if I add the other assignment to it, the price will no longer be 20K. It's going to increase again. So we'll leave the amount that is going to increase by to board. We'll decide the class for next week. For Gaskia, that's by the way. I wish you all very very absolutely good week. Even though I don't see my Valentine's gifts, I won't complain, because I know that my gift is with God. So, Odabo, for those that don't understand Yoruba, it means goodbye. You can all leave the call. So I want to end the recording.
Mhm.